Hello, ladies and gentlemen, and thank you for listening to Mr. Laxton's video on this Chapter 8 practice test. So this is going to be a decently long video, so if you just have a question on a specific couple questions, you can just fast forward it to there. So I'm just going to talk through all these guys, see what we got here. Alright, this first one asks us whether we have exponential growth or decay. So here's where we look at this b value and see if that's greater than 1 or less than 1. So we see that 1.5 is greater than 1, so that means that we have exponential growth here. Alright, so going on to number 2, we just have to plug some of these guys in and go here. So if I look at number 2, it says I invest $3,500 at 8%. That's compounded quarterly. What will the investment be worth in 5 years? Show your work. All right, so if we look at this guy, we have to plug these guys in. I get y equals, I put that 3,500 in for my initial a value. And I'm going to have 1 plus 0.08, don't forget to move that decimal place 2 places there, over 4 here. That quarterly means that my n is 4. It happens 4 times per year. And I'm going to raise it to the 4 times 5 here, my n times my t. Alright, so if you go through and put this all into your calculator correctly, you should get that after 5 years, you should have $5,200.82 in your account. Alright, so that is the answer to number 2. Going on to number 3, we have the value of a new car purchased at $15,000 depreciates at a rate of 10% per year. How much will that car be worth in 5 years? So we look here, it has plus or the minus, we look. And if it's depreciating, that means that we have minus here in that equation. So we have y equals 15,000, 1 minus 0.1, move that guy 2 places, to the 5th now. Alright, so if I set this guy and I put this guy into my calculator, you should get an answer that that car is worth $8,857.35. Alright, so make sure you're putting that guy in your calculator correctly. Alright, number 4 I would say is probably one of the tougher questions on the test here. So it says that you invest $1,000, that's going to be my A, alright, at 5%, that's my R. Compounded quarterly, that's N equals 4. And then it asks how long will it take to for your investment to double in value. Alright, so now if we look and plugging this in, this one we actually know my y. If I invest $1,000 and it doubles, that means that I'm going to have $2,000 at the end of this time period. I'm going to set that equal to 1,000, 1 plus 0.05 over 4 to the 4 times t here. And we're trying to solve for that t now. So this is kind of a different one compared to the other ones. Alright, so now if I go through here, I can just solve this guy for t. So I can divide this guy by 1,000. So now I get that 2 equals, and if I put all this into my calculator here, I get that is equal to 1.0125, and that is still raised to the 4t here. Okay, so now we talked about in class about how to solve these exponent equations. So we talked about when in doubt, change that form. So this is an exponent form right now, so I'm going to change that into log form. So I'm going to take the log, and remember that this is going to be my base, whatever that number is, so it's 1.0125, and I'm going to take that log of 2 equals 4t. Alright, so now you can just go through and plug this guy into your calculator, and if you plug log of 2 and divide it by the log of 1.0125, you should get 55.798 for that, and that's still equal to 4t. Divide this guy by 4, you should get your t is equal to 13.95 years. Alright, so that one's a little bit different there. All right, going on to 5. So we got some changing forms for 5, 6, 7, and 8. So we have to write this in exponent form. So always remember that that base number is going to be your base, your exponent. I have 7 to the 2 equals 49 is how that one works. 6 is going on the same way. That 9 is your base. 9 to the 3 equals 729. All right, going on to 7, we have to write these guys in log form now. So these go back and forth the other way. So now I take log, and then that base is my base of my log. So log base 3 of 9 now equals 2. All right, so that's how you plug that guy in there. Now going on as well, we have number 8, which is going to be log base 3 of 1 over 27 equals -3. All right, now going on for numbers 9 and 10 here, we have to expand these logs. So we're going to make these into more than one log. So if I look here, my log, I see that I have some multiplication here. So if you look into those properties, we know that with multiplication, we can break that up into 2 logs and put a plus in between them. So I have log of x cubed. All right, so now I put a plus in between those guys. That means multiplication here. And now that last step, I can bring that 3 out in front. So my answer is log of 4 plus 3 log of x. So that is my answer there. Going on to number 10, kind of the same thing here, except for now we have this division. So that division means that we need to split those guys up into the log of x to the 4th minus the log of 5 now. All right, now again, that 4 can come out front. I have 4 log of x minus log of 5. So splitting those guys up, expanding them, making them into more than one log. All right, so we have the first page done there. Moving on to the second page here for numbers 11 and 12. So numbers 11 and 12, we're asked to condense these logs. So we're supposed to bring them into one log. So your answer should have one log here. All right, so here I always like to look at these numbers that are out in front, and I bring those guys to those exponents. All right, so this guy turns into the log of 6 squared minus the log of 3 minus the log of 2 squared. So now I can go through and tell you what these guys are. So that's going to be the log of 36 minus the log of 3, that guy stays, minus the log of 4. All right, and now here we have all these minuses that are in between. We have that minus and we have that minus. So if you look, when we're doing those back and forth in number 10, that minus means that in one log we're going to divide these guys. So now this is going to be the log of 36 divided by 3 minus the log of 4. All right, so here if I bring this guy up here, I have the log of 12 minus the log of 4. And again, I take these two numbers, since that's a minus, and I can divide them. So now my answer is the log of 12 divided by 4, which is the log of 3. All right, so going on here to number 12. This one's a little bit quicker, a little bit easier. You bring those exponents from the front to the back. So now we have log of x to the 5th plus the log of y to the 3rd. Okay, now this plus means that I can take these two guys and multiply them in one log. So I have the log of x to the 5th times y to the 3rd. That is a 3. That is my answer there. All right, now going on to number 13, we have to find some inverses here. So for finding inverses, the first thing that we always have to do here for inverses, number 1, is switch x and y. So instead of writing y, I'm going to write x equals log base 5 of y. Number 2, I am going to switch the form. All right, so switch the form. So now this is in log form, so I'm going to make it into exponent form. So it's going to be 5 to the x equals y. And that is my answer. The third step technically is to get y all by itself. So, but here we have that y all by itself. Y alone, I'll write there. All right, so now in 14, we talked about this guy in class a little bit, that base of that ln is e. So I'm going to write that as x equals ln base e of y plus 12. All right, so if I go through here, that is my first step. I switched my x and my y. Now I need to switch the form. So I switch it from log form into exponent form. So this is e to the x equals y plus 12. Okay, can subtract that 12 the other side. I get e to the x equal, e to the x minus 12 equals y. Final there. All right, we're getting there, folks. We're getting there. All right, so 16 or 15 and 16 are asked us to simplify, and I like to set those guys equal to x right away, and we're going to find out what that x value is. So here, if I change the form, this guy becomes 4 to the x equals 16. And you have to ask yourself, 4 to what power gives me 16? And that would be 2. So 4 squared gives me 16. Here, I bring it 3 to the x equals 81. All right, I have to ask myself, 3 to what power gives me 81? And that is 4. So I have x equals 4 here for that guy. Number 17, I set this guy 2 to the x equals 1 over 16. All right, now I like to ask myself, 2 to what power gives me 16? And I know that my x has to be 4 because 2 to the 4 power gives me 16. But since it's in the bottom, that means that this guy's going to be negative. So I have x equals negative 4 there for that one. All right, 18, you can kind of just treat those e's like they're x's. So you just have to use them as kind of these variables. Talking about those exponent rules, excuse me. So now we have this, take this negative 2, multiply it by that 4, you get negative 8. Now you have e, and then you take that 5 and you 2, and then you add those guys together. So you get e to the 7th there. So quick one there for 18. All right, 19, this change of base here. Find what log base 25, base 6 of 25 is. So we're going to put in log of 25 into my calculator. And then I'm going to divide that by the log of 6. So that's how you solve this guy into your calculator. So if you put that in there, you should get 1.797 for your answer. All right, number 20, we have to solve this guy. This guy's in an exponent form right here. So I'm going to have to change it into log. So I'm going to make this the log base 7 of 150 equals x. All right, so if I put this guy into my calculator, just like we talked about in 19, if I can put that guy in there, I should get that 2.575 equals x. 21 going, we have both these guys in exponent form, and notice that my bases are not the same, so I have to make the same bases there. So I'm going to make this as 2 to the 4x is equal to, then how do I write 2 as a base to make 8? So that's 2 to the 3rd power, and then I have x plus 3 still. So I'm going to replace that 8 with this 2 cubed here. All right, so now I can bring that cubed and multiply that by the x and the 3. So I get 2 to the 4x equals 2 to the 3x plus 9. All right, so now once you have those same bases, you can just cross those guys out. So you get 4x equals 3x plus 9. Solve this guy for x, you subtract that 3x. So you get 1x equals 9. Should be your final answer there. All right, awesome. Getting on to the last page here. It asks us in number 22 to solve that log. Okay, remember, when in doubt, change the form here. So this is going to be 5 squared equals x plus 4. All right, so now if I plug this guy in, 5 squared is 25, and I can subtract that 4 from both sides, so I should get 21 equals x here. All right, good, good, good. Going on to number 23, we have some logs here on both sides. If they're on both sides, cross them out. So we have x minus 8 is equal to 4x plus 7. All right, now I'm confident we can get this. We can subtract that x over. We can subtract that 7, subtract the 7 to both sides. So I get negative 15 equals 3x. Divide that guy by 3. So you should get negative 5 equals x for number 23. All right, 24 is like these exponent models that you guys were liking a lot in class. So we have this y equals ab to the x. So to find this exponent model, we can plug these guys in. I get 8 equals ab squared. And then I have 16 equals ab cubed. Okay, just plugging those x, y's in for those equations. All right, next you have to solve one of those equations for a, so I'm going to divide this guy by b squared, divide this guy by b squared, so now I get that a equals 8 over b squared. And I can take this 8 over b squared and I can plug it right in there for a, so I get 16 equals 8 over b squared and then b cubed. So this guy can simplify, that 2 can cancel out with 2 on the top and leave you with 1. So now this guy turns into 16 equals 8 b to the first. All right, so if I look here, if I solve for that b, I can divide by 8 to both sides. So I get that 2 is equal to b. All right, so I got 2 is equal to b there. All right, now going through and solving this, I have to find out what my a is. So I'm going to take my b and I'm going to plug that into this equation over here. So I get that a equals 8 over my 2 squared. So that's going to be 8 over 4, which means that a is equal to 2. So both these guys are equal to 2. So my final answer should be y is equal to 2 times 2 to the x. All right, final one there. All right, so for 25, we have, this is just a really fancy way of asking us to find what is my h, all right, what is my k, and how does that move my graph? So if I look here, my h is -2 and my k is -1. So that k means that my graph is going to move down 1, and that h is -2 means that it's going to move left 2. All right, so that is for 25, all you need to say there. All right, for 26 and 27, these are some graphs here. We get y equals 1/2 to the x here. That is my parent function. All right, my parent function for 27 is just that y equals log base 3 to the x. Okay, so if you look through that green sheet that I gave you guys in class, these graphs should be pretty self-explanatory with the range and the domain here. Just because this video is getting a little long, I'm going to try to cut it off here, but just remember for 27 here that you need to change this form. So this is going to become 3 to the y equals x. So that's why we plug in those y values first, that -2, -1, 0, 1, and 2. Okay, because you plug those guys directly into this y right here. All right, so that makes it pretty easy to graph. Move it with your h and your k. So if you have any questions on this 26 and 27, please come find me. If you have any questions with any of the questions on this practice test, please come find me and I'll help you for the test. Be ready for the test, do well, and we'll talk to you later.